Many electrical problems are not as hard to fix as they are to find. And there's two reasons for that. One is you can't see electricity, and the other is you have to test for it. And there's a process to be successful at that testing. That's the lesson of this video, the testing process. We're going to show you in this video, well, first things first, always confirm the complaint. Now you're going to have questions as you go. You will get your answers from the diagram, and we'll show you how to do that. Now test all the parts, not just the ones that you suspect. Use your logical thinking. Isolate circuits as you test them, and the power probe can be very helpful. Test even known good parts to be sure they're good. Understand continuity. We're going to show you how to use a voltmeter and check the checker, because oftentimes that's the problem. Looking for evidence will lead you to the problem, and always be sure to make a professional repair. Details matter. This video is very detailed, and your skills matter. Your skills should be very detailed as well. So for you serious about learning, here's a lesson to learn from.
Today we're going to be taking a look at a 2002 Ford Explorer. The customer brought the vehicle in with the complaint that the right rear window is not functioning properly. Let's go ahead and confirm the customer complaint. Now I'm holding the button down on the right rear window switch and nothing's happening. We're going to try to operate it up, and I'm holding my thumb on the up position and nothing is occurring. So we don't have any commands from the right rear switch. I'm holding the button down and nothing is happening, as we can see. And then as I hold the button up, nothing is happening again. Let's see if we can command any of the other windows from the driver's side master switch. Okay, the driver's side window is rolling up and the driver's side window is rolling down. Let's try the passenger side front. As we can see, we do have good power from the main switch. Let's try the driver's side rear window now. There it goes down, and there we have it going right back up. Now, as we look at the diagram for the early build, we can see that in the master switch, the ground is shared to all the controls.
So here's the diagram for the master window switch. Now our problem is in the right rear, so that's all I'm going to focus on right now is the right rear, which is right here. Now this switch has power and is provided by a fuse, and it goes to the right rear switch. We also have ground. It's a common ground that feeds all these circuits. So we have a ground that travels down to all of the different windows. This is the switch at rest. Now from the master switch, our switch number 4 for window number 4, the right rear, is simply going to toggle power to one side. It already has ground, so that motor should run, or it'll toggle the other way, and this would be the power and that would be the ground. Now since we have a problem with switch number 4, we must have a problem with either this red-black wire or the yellow-black wire. One of these two wires is our problem.
By using the master switch to check all the other windows, we've confirmed that the switch does have good ground to it. Before we move forward, we want to go ahead and test the motor for proper operation. It's key to do that so that you don't replace something that you don't need to. Now, as we look at the diagram, we can see that the motor is operated with ground on both sides of the circuit, with the switch controlling which side power is given to. Now, that's a reverse polarity motor, so as we push one way, power is provided on one side of the circuit, and then as we change the switch the other way, power is provided to the other side. Now what I'm going to do is disconnect the vehicle harness from the motor. That way the motor is removed completely from the circuit and I can test it as an individual component. Right here is where the window motor harness connector is. I can simply pull this apart here. Now, because we have the motor out of the circuit, it no longer has ground provided to it from the vehicle. Now our power probe has a ground strap on it that we can use to provide ground to the circuit. So we're going to go ahead and place that on one side.
Number 1 here.
When I place the power probe on the other side, That should be a closed circuit. Now as that light comes on, that tells us that we have a good circuit and good ground. Now you saw the window go down, so what I need to do is manually reverse the polarity, see if we can get the motor to go back up. Okay, now we know our motor's good, so what we need to do is go and test our switches. Now we know there's many different ways to check a circuit and to check a switch, but one thing I'm going to do here is remove the switch. I'm going to take it up to a known good window that is operating and see if it operates that window. So I simply remove the switch by pressing down on the connector, pulling it off. Then we'll go up here to the front window. We're going to take the right rear switch, which is in question, and plug it into a circuit that is known to be good and see what result we get. There we can see the right front window going down and the right front window going up. So we know that our switch is not the problem on the right rear. We know that we can operate all the other windows from the driver's master switch except for this window. We know at this point that it's not the right rear window motor. We know that it's not the right rear switch because it worked on another circuit. So now what we need to do is check and see if there's a problem between the driver's master switch and the right rear switch. Now if we look at our diagram, we can see that the two wires coming from the driver's master switch to the right rear switch are yellow and black and red and black.
Now looking back at our diagram, we saw switch number 4 that was simply toggled. It had ground to both sides of the motor and it was toggled at the master switch. Well, the red and black is indicated by number E and the yellow black by F when we go to diagram 100-4. Here is diagram 100-4, and you can see our E red with black and our F yellow with black. Now these grounds just simply travel right through the motor because there's continuity, and then at switch number 4 it is toggled between 1 and 2 up and down. So either the right rear switch can run the motor or the master switch can run the motor.
Now these wires have to be good in order for our circuit to operate properly. Let's go ahead and do a continuity check. Now keep in mind that a continuity check will only let us know if there's an open in the circuit. It will not test for high resistance. At the right rear switch, what I'm going to do is take a back probing pin and plug that into the connector on the red and black wire. As you can see, this wire is really long, that way I can reach my voltmeter. Then what I'm going to have to do is back probe from the other side with another wire and connect both leads to my voltmeter so I can do a continuity check. We're at the driver's master switch now, and what we need to do is remove those wires from the component because in order to do a continuity test we can't have any components in the circuit.
This switch must be disconnected from the vehicle's power because our DVOM will provide the power. If the vehicle's power is there, it'll interfere with our test.
Now I'm going to do the same thing I did on the right rear switch and back probe the red and black wire. Now I'm going to run this back to my meter. Now I have the blue wire that's back probed on the right rear window switch, and I have my white wire back probed on the driver's master switch. So what I'm going to do is hook the blue wire to one lead on the voltmeter, and I'm going to hook the white wire to the other lead on the voltmeter, and we should be testing for continuity. When we're setting up our voltmeter for this continuity test, let's make sure that we have one lead in the common hole, and then we have another lead in the volts and continuity and ohm hole. Let's turn our voltmeter on and put it on the right setting. We're going to set it down here on the continuity test, and you can see by the symbol when we place our leads together or close any circuit, it's going to beep, allowing us to know we have good continuity. Let's go ahead and check our voltmeter and make sure that it's working properly. Now we're showing out of limits here, which means we have an open. So when we place our leads together, it should beep and tell us that we have continuity. Alright, I've got the blue wire on one lead on my voltmeter, And now when I place the white wire from the driver's master switch on the other lead, we should get a beep confirming that we have good continuity. And there you have it, good continuity on the red wire with the black stripe. Now I'm going to take the back probe that we had on the red and black wire out of the connector, and I'm going to put it on the yellow and black wire. Okay, now that I have that there, I need to go up to the front on the driver's master switch and do the same thing on the same wire. Now our blue wire is back probed into our yellow and black wire on the right rear window switch, and our white wire is back probed on our driver's master switch yellow and black wire. So now when we touch the lead to the white wire, we should get good continuity. Now as we can see on our voltmeter, we don't show any continuity or showing out of limits, which means on this wire, if we have it connected correctly through the circuit, has an open in it somewhere. With our continuity test, we've just proven that there's a break somewhere in the circuit between the right rear window switch and the driver's master switch. Now just a tip, on most vehicles, the right rear door is not typically open as much as the driver's door is. So let's go there real quick and take a look and see if there's a problem. We're up here at the driver's side door, and over a period of time, years and years of this door opening and closing, the wires that are in this loom and this harness where the door pivots get pinched over time. So this is the first place we're going to look and see if we have any damage. What I want to do first in inspecting these wires is try to remove what I can of this cover. Now we should just be able to pry it out from the door, and we're going to pull it back and inspect the wires. Now keep in mind that we're looking for a yellow wire with a black stripe. May have to move these wires around just a bit to find it. Yep, and there we have it right there. There's our yellow wire with the black stripe, and it's broken. That's our open in our circuit. Now let's see if we can't find the other end of this wire. And there it is. Now what we're going to have to do is get better access to repair this wire, because I can hardly get my hands in here, and I'm not going to be able to get any tools in here to make a repair. I'm going to go ahead and take the panel off the driver front door. Now how I got access to this wire is to remove the rubber cover from the driver's side. Simply by pulling it out here. And then what I found out I could do was kind of work it back and forth in through the door. If you turn it sideways there, it kind of comes out of your way. Now we have better access to this wire. We can see it a lot better. I'm going to remove this electrical tape from the harness. That's going to allow me to pull that wire back here where I can work on it better. The tape here is just keeping the wiring harness bundled together. Now I've chosen to pull the wire back through the door for my repair. Accessibility is really key when you want to get a good solid repair. These wires are stretched tight anyway, so what I'm going to do is add a length of wire that'll give me a little bit easier repair to make, and that way I'll know it's solid. We want to do this professionally, so we're going to solder this in and make sure we do a real solid repair. Now I'm going to run this long wire here through the door. Okay. And then I get this wire ready to solder. Need to remove the insulation. And I'm going to go ahead and put my heat shrink on one side. Let's make sure we have a good connection here. We're ready to put some solder on. These little alligator clips that we have on here are really handy. They hold the wires together and support them while we solder. That way they don't move or nothing comes apart as we're making the repair. And they have little magnets on them so you can stick them to anything metal. Now that we've got our wire soldered, we're going to cover it in heat shrink. Now we cut this piece of wire a little extra long, that way we could work back and know that we had enough. So we're going to feed this back through the hole. And then we're going to solder this end of the wire. Now we're going to cut this wire down a little bit more now that we have a better idea of what kind of length we need. And it's okay if we cut it a little long, so we can just tuck it in. It's all going to get taped back together. Now we're adding more wire to this, but by doing that we're giving ourselves better access to make the repair. This is just making it easier. Alright, now we're going to place the heat shrink on this end of the wire. Okay, now we've got our wire all repaired, and before we button everything back up and put everything back together, let's go ahead and try the window and see if it works. There we can see it going down, and there it is going back up. Now that's from the driver's master switch there that it's working. Alright, let's try the window from the right rear switch. There it is going down, and there it is going right back up. We looked for evidence and we let it lead us to the problem. And our problem was a broken wire in the circuit. Now we made our repair, we checked our repair, and now I just need to put everything back together.